Hi, in this video, let's see how to develop the classification model from end to end. Firstly, let's download the data from the calculator site. Click on this one. So under the data card section, scroll down, click on the download symbol, and the file has been downloaded. And let's go and open the terminal. If in case if you're using Windows, use the command prompt. So Jupyter notebook to initiate the Jupyter notebook. You have the Jupyter notebook here. Let's upload the downloaded file. I have downloaded the file, so I'm just copying the name of the file. And now let's create a Python notebook. So classification ML model end to end. Let's do this one. Let's import libraries, right? Import pandas as PD, import numpy as np, right? Import warnings, import pickle to save the model, and from sklearn model selection, import grind test split, which is required. And what else from sklearn? Let's import the machine learning model dot ensemble, import random forest classifier. What else we could have? I mean, let's go ahead with this one. We can also see the metrics sklearn dot matrix, import classification report confusion matrix. And also we can see from sklearn dot matrix, import accuracy score, precision score, recall score, and f1 score, right? Fine. So let's import the data. So df is equal to pd dot read. This is a CSV format file. So I'm just uploading this one here. Low memory. This is an optional one. Is equal to false. Df dot head. Okay, fine. Let's see how many rows and columns. 1025 rows and 14 columns. Let's look for the blank values. If there's any blank value, I would like to replace with none. In place is equal to true. Let's look for the none values. Nothing is there. So let's look at the data types. You can either use d types. You can either use this one or df.info also works, right? Now let's see statistics describe, right? Let's split the data. Let's look at the data. So sorry. So now from age, I mean, basically this data set represents whether the person may get a heart disease or not. 0 represents no heart disease and 1 represents heart disease. Let's see what are all the values with this one. Dot value counts. So 0 represents no heart disease and 1 represents the heart disease. So how you can know this one? Just go back to Kaggle heart data set and just go through all the list of details over here to understand about the data set much better. So and also the values is like here 1 and 0. If we go to sklearn map, and if we go here, so let's start from here. More than 50 samples. Yes, predicting a category. Yes, 1 0. Yes, we have to go with the classification, and all of these are the models that we can use. And for now, I'm just going to use the ensemble, which is a random forest classifier for this example, right? First, let's split into x and y. Let's split separate features and labels. Okay, x is equal to df dot, instead of writing all these names, I'm just dropping this one. So drop columns is equal to target, axis is equal to 1. Axis is equal to 1. Why we have to write this? Because we are dropping the entire target column. and y is equal to df. I just need the target column here, right? Let's look at the x data. There is no target column here. Let's look at the y data. This is also cool. Let's split the data into training and testing. Test split. Why we have to do this one? Let's go back here. So if you have the original data set, so I mean now we have like 1025 rows, right? 1025 rows, 25 rows. So I'm gonna split this 1025 into training data and test data. For training data, I'm going to give like 80% of the data. So this is the data where we are going to train our ML model, and the remaining 20% of the data I use this for the testing purpose. Right? Let's go back. Split the data. For this purpose, we already imported this train test split here. So the same one. Np dot random dot seed, you can use like 42. Basically, if you put like the same value for in your system as well while doing this one, whatever the split that happens to me, the same split happens to you as well. Now x train, x test, y train, y test is equal to train test split of x comma y, right? We have this x and y here. So I want the test size to be 20%, which is like 0.2. The random state, I mean, some people they prefer np dot random state. Some people they prefer this the random state. Either one is fine. There is one called which is called stratify. This is only used for classification models. So stratify is equal to y. Basically, this helps to split the data. Like I mean, for example, we have like zero and ones, right? So people who has no who may get heart disease, who may not have heart disease. So this the split happens like equally for both of these. So this is good. And now let's see x train dot shape. How many 820 rows? X test dot shape. How many? 205. So how you can see length of df into 0.8. So this is like 820 for the training data. Length of df into 0.2. This is for the testing purpose. Okay, now we have the data. Let's train the ML model from sklearn dot ensemble import random forest classifier. Instead of writing this every time, I'm just going to give a name. Rf is equal to random forest classifier. Believe me, I mean, if you're practicing the code along with me, basically like the way I have shown in my videos, so you will practice a lot. Whenever I am typing the code, I recommend you as well to do the same. So you also get hands-on experience and practice so that you will be more comfortable. So n estimators is equal to 100. So I mean we don't have to mention this one because anyways this is a default value. For example, if you go to random forest classifier, so let's see this one. So this is the random forest classifier. This is how the data will be split. This is one tree, two tree, three, and four. And these trees are nothing but estimators. One estimator, two estimators. So now we have given like estimate n estimators is equal to 100, right? So basically, this is going to create 100 trees, and it is going to take the majority voting, like which one gives the best accuracy and all, and it will be considered as a final class. So basically, the scikit-learn does all the calculations for us. So this is done. RF. So now the model is we have this model. We have to fit the data, right? And how we can fit the data? RF dot fit. What data we are going to fit? So the training data, X train and the Y train. So X train, Y train. Okay, this is done. If in case if you're handling a large data set, and sometimes it takes more time. So if in case if you wanna see how much time it takes, just put like these are the magical symbols, magical symbol, percentile, percentile, and time. You can see how much time it takes. This one, it is like 109 milliseconds. It's just 1 second, around 1 second. Now rf dot score extend. So now we have the model. Now let's see, if I give the training data, how much, what is the accuracy? The accuracy is like 100%, which is good because this data the model has already seen. We fit the data here. So X test data, I mean, we haven't used so far. Now I want to see how, what is the score for the unknown data, right? Sorry, X test and Y test. Hmm. Okay, this is also one which is good. Our model is performing like 100% accuracy. And now let's predict the values. So how we predict the values? Okay, so if we go back to this one, if you look at this one, so basically we have this X data, X train and Y train training data, and now we are going to predict the values based on the X test. So we have X test and Y test. So these are like some 220% of the data, and we know what exact the values as well for this test data. And now we are going to predict the values. We are using the ML model on this X data, and we will get some results, right? Some values like 1010, something like that. And those values we are going to compare with the actual values. So basically, using on X test, we are going to predict the values, and we are going to compare the predictions values against the original Y test values to see like how accurate the model is working. So going back, so I'm going to name it the predictions. This is a prediction one. So our model name is rf dot predict x test, right? Y preds. Okay, this is how the ML model predicted. And now, for example, if you select x test of one, two, okay. For example, see this one, x test of one, right? So this is the row, and for this row, I mean, if the person age is 64 and if he's a male person, if the chest pain type is 0 and if the person maximum heart rate is 96 and everything, let's see what is the prediction of this one. It is 0. The person may not get the heart disease. For example, let's take first two records, right? So the second person age is 57, who is bit younger than the first one. The person gender is male, and he has the maximum heart rate of 126. Okay, and now let's see what is going. So he may get the heart disease like that. So instead of just giving 1 and 2, I'm just going to give for the entire data set X test. So these are the values, and now these are the Y test values. These are not easy to compare, right? So what we can do, I'm going to use NP array of Y test. Okay, this is how I get the values, but still, mm, you know, these are not easy to compare, right? For example, let's delete this one. For example, let's see X test for two values. What is the prediction? Is 0 and 1 for the, these are the prediction values, and what is the original values as per the reports? 0 comma 1. See, this is all matching actually. But when we do the predictions for the entire data set, it's not intuitive to calculate one by one, right? So let's see NP of mean Y test, the actual values and the prediction values. Sorry, is equal to this one. Oh, it is like 100% because we already have seen the score is 100%. So this is like 100%. Let's see. I mean, instead of doing like this mathematical manual calculations and all, what else we can do? So we have modules like ML model evaluations, the metrics actually. Let's see from so sklearn dot metrics. I already have imported this module at the beginning of this in the first cell. Import accuracy score, right? So now print accuracy score for what we are calculating the accuracy, to see what is the original value and what is the predicted value. The score is like 100%. This is really good, right? So similarly, we can also do the precision and all. Uh, so print precision score of y test comma y preds. Okay, this is also 100. But what is this precision actually? So we have one more. Recall score of y test comma y preds, right? And we have f1 y test y preds. This is f1 score. But what are all these? I mean, accuracy. This helps us to understand whether all the predicted values and against the actual values are correct or not. This is good. But what is this precision? What is this recall? And what is this F1 score? So let's go back to this one slideshow. So here you can see this one. So let's have a conversion matrix. So basically, I'm going to explain this in the later part of this video. So let's put, like, for example, if the actual is no, for example, the person has no heart disease, but the predicted is no, that is fine. That is fine. But if the actual is no, I mean, the person has no heart disease, this is like right. I mean, there is no, I mean, the actual value is no and predicted is no, that is like, it is good. But if the person has no heart disease and if the prediction is like yes, it's a false positive. Basically, it's a wrong value, right? And if the actually the person has a heart disease and if the prediction is no, and if the person, I mean, this is like false negative. So basically there is a heart disease and we are telling to the patient that you don't have a heart disease. That is absolutely wrong. And if the person has a heart disease and the prediction is also yes, that is true positive. So for example, no false positive, right? And no true and yes true positive, only true, this is called precision. And no false negative, this is like the dangerous one because they have the disease and we are telling them no. No false negative is equal to recall. And the combination of precision and recall is the F1 score. The support is something that you can see in the classification report, where it helps us, I mean, on how many samples that it has taken to perform these calculations, right? So let's go back to here. Let's do the classification report, right? So from sklearn dot dot matrix import classification report, comma, confusion matrix as well. Let's do the confusion matrix. Okay, let's go with the classification report, right? And now let's see. Mm, print classification report of y test and the y prints. So now everything is 111. Basically, the data set itself is like that. Maybe next time we should get some data set where we can get like some differentiate in the values and all. And believe, I mean, always look at the weighted average. The better the weighted average, the better the model performs. So this is all about the precision, recall, F1. The support is like number of samples it has considered. For, I mean, I mean, for zeros and all, I mean, consider like 100 samples, and this one 105 samples. The total is like 205 samples. Let's see mm, the confusion matrix, right? Mm, from sklearn dot matrix import confusion matrix. So let's do this one. Confusion matrix of y test, comma y prints. SNS import matplotlib lib.pyplot as plt. Now this one sns dot set font scale, just put it like 1 so that it looks good. Scale for font scale. And plot dot figure size, I'm just want to give this one as like some 5 by 5. SNS dot heat map, let's use the heat map. Let's put the title as like heat map. That would help, right? So what is the this one? We are trying to predict this one, confusion matrix of this one. Update here, comma annotations. I want to see the values, so true. And I don't format, actually this one you don't have to keep, but I'm just keeping it here. And what else we can show here? Colors, let's put like C map is equal to blues to make it like little bit good. C bar is equal to false. I mean, just play with these values whenever you're doing this one. This is running, that's the reason you are seeing the star and all. Okay, let's put some title here. Plot dot title. What is this one? Confusion matrix. and plot dot show helps. And then I want to put this one matplot lib inline. So basically this helps to keep all the values in line. What is there on x-axis? Plot dot x label, it's actual values. Plot dot y label, it's predicted values. So now you can see, so actual values are 0, and the predicted values are 0, which is like 100%. Actual values are 1 and the actual values are 0, and then so you can see here 0, 100 and 105, 100. I mean, so basically, actual values are 0, and the predicted value 0 is like 100. Like there are no, like actual values are 0, and there is no predicted ones. No, actual values are 1, and the predicted values are 1. It's a 105, and this is 0. This is absolutely correct. And this one is done. So what else we can perform here? So our accuracy is already 100%, right? So we can't. But let's see how is the accuracy with the different estimators. Play with accuracy. Well, I mean, by changing the estimators. For example, so what is from sklearn dot ensemble import random forest classifier, right? This is our model. So CLF, I'm just naming a CLF random forest classifier. If you remember, I have given estimators here, but I'm not going to give the estimators here. So for I in range 10 comma 100 10 times. So basically I'm gonna do like 10. What is this? If the estimate is 10, if the estimate is 20, how it's gonna work at all? So let's see, clf dot fit x train. Let's fit the data. Y train, right? Clf dot um, what we can do, I mean, but even before fitting that, we have to pass this one. So clf is equal to random forest classifier n estimators is equal to I. So this value is passing to here, and from here, so print f this one model accuracy on test set with estimators. So if we put it like I here, this would work. So here this one works. Model dot score, what is the test set data? X test comma y test. Let's multiply it by 100 because we're getting in the decimal formats. 100, and then I just want to after two decimal points and this percentage here, and I'm going to keep this n so that we'll get a new space. So the model is nothing but CLO, sorry. See, when the estimator is 10, the accuracy is like 99.99 only. But when the estimate is 20, is 1992. And for the rest of the estimators, it is 100. I mean, when we are changing the estimators, the accuracy is like increased. This is a good way, good sign. So, and now let's see how we can save this model, save the model. So, I'm going to use import pickle. So pickle dot dump. So what is our model name? CLF, right? Open random forest one dot pickle format. I'm gonna write the book. This is cool. Now let's. I mean, once this is like done, next time also you don't have to run this entire one whenever it is in the production and all. You just have to load the saved model. Load the saved model. So how you can do? Um, So what is this one? The pickle name is this one, right? So pickle dot load open this one dot pickle comma write book. Yes. So I'm just going to give a name as like a loaded model. And where you can see this one, you go here and you can see that one here actually. Just give a moment, it will show. Hmm. It will show. Yep. RF one pickle. So just take this one. Yep. So if you wanna see predict the values, so predict x test of one, it will predict the values for you. See, this looks so cool. And we have one more concept called ROC curve. Let's see how that looks like in our upcoming videos. Thank you. Have a good day.